Okay, this is the homework help video for Unit 5, Objective 1, Honors Math 3. So the directions for the beginning are to simplify the radical, and then you also have to kind of pay attention to absolute values. So what we're looking to do here is we're looking to square root 9c to the power of 4 and d squared. So we don't have to write this piece out, but I'm going to just for the sake of trying to understand it. So what we're doing is we are taking the square root of 9, right? And we are taking the square root of c to the 4th, and we're taking the square root of d squared. So this would be like a mental math kind of step. We don't need to write this out. I'm just writing it out just for the sake of explanation. So here we would take the square root of 9, which is just 3, and then the square root of c to the 4th. So there's an implied index of 2 here. So we would do, how many times does 2 go into 4? And it goes in twice. So that would be c squared. So 4 divided by 2 is 2. And the same thing here. So there's an implied index of 2, and so the square root of d squared would just be d to the power of 1. And then we don't have to put the 1 here because that would be implied. And then we do need to check to see, do we need absolute values or not? So we look to see, first, is the index here even? So it is, so that means we need to be thinking potentially absolute value. And so these are also both even. So again, that means we need to be thinking absolute value. So because we have an even index with even powers, we have to check to see, will our value stay positive or not, right? Because rooting an even power, all of that would be positive. So if I did c squared, regardless of c positive or negative, this would stay positive, so I don't need absolute value. The root and d squared should result in a positive value. So if d were positive, that would be fine, but what if d were negative? That would not be positive because a power of 1 would be a negative, could result in a negative value. So we have to have absolute value, okay? So again, all of this would be positive, right? Even powers always generate positive values, okay? But this turned into an odd power, so would not always generate a positive, so we need absolute value. So even to odd, absolute value. Even to odd, absolute value, okay? All right, and then let's take a look at number 3. Okay, so for this one here, so we have that negative 3x is that coefficient, so I'm going to go ahead and just kind of have that hang out in the front here, and then this is an even power. So when I look at this, I know that this is even, this is odd, so x is already has to be a positive number because a positive odd power, right, is going to be positive. We can't let it be negative, so negative to an odd power would be negative, which is not good, right, because that would be a complex number. So we know that we don't have to worry about this odd power, don't have to pay attention to absolute value. This one we do, right, because y squared, anything squared would turn positive, so this one we have to think about. Okay, so the square root of 81 is 9. And then here, this is odd, so we're going to do some like mixed number division. So we know it's going to be x, and then 2 goes into 7 3 times, right? With the 1 left over, and that 1 left over is going to stay in the root, right? So 2 goes into 7 3 times with 1 left over, and the 1 left over stays in the root. And then now we have to do the square root of y squared, so that would be 2 divided by 2, which is 1. All right, so now let's look at absolute value. So we have odd power, no absolute value. Even, that turned odd, absolute value. Okay. And then now I'm going to just multiply that together. So negative 3 times 9. And then x to the first, x cubed. So add our powers when we do that. So that would be 1 plus 3. And then absolute value of y. And then we still have the root of x. Okay, so one more time on that absolute value. We started out even on the index and the power, and it turned odd, so we need absolute value. Okay. All right, and let's take a look at number 9. So this one right here, so this is a cube root, so as soon as it becomes a cube root, this is an odd index, so we can have positive, negative numbers, it doesn't matter, right? Because the cube root of negative is fine, cube root of positive is fine, so we don't have to worry about absolute values. So then we just have to find the roots of everything. So 16, I need to know my cube roots, so I'm going to go ahead and just break that apart. Again, not because I have to, just so I can explain that. So 16 I know is either 4 times 4. Well, it's 1 times 16, of course, right? And then 4 times 4, and 8 times 2. And so those are all my factors of 16. And so I'm looking to see, like, what do I know the cube root of? And I know the cube root of 8. Not 2, of course, but I know the cube root of 8. I don't know the cube root of either of those. And then doing 1 times 16 is not going to help me simplify. Okay, so then I'm not going to use that one either. So then for 16, I'm going to write that as 8 times 2. And then, of course, I have the x to the 4th and the y to the 9th. So the cube root of 8 is 2. This will stay in here. And then I have, so let me go ahead and give myself a little bit of room. So cube root of 2, can't do that. So for x to the 4th, so 3 goes into 4 one time with 1 left over, right? So 3 goes into 4 once, so that pulls out with 1 left over, the leftover staying in the radical. And then 3 goes into 9 3 times with none left over, so then it would just look like that. And then, of course, I don't need that x to the power of 1, I could just write it as x. And then that would be the cube root of 2x. Okay. All right, and then now we have question number 20. So for this one here, we have cube roots again. So that means we don't need to worry about absolute values at all. So I can plan or work this problem out multiple different ways. So I can go ahead and multiply my coefficients and the radicals together first, or I can simplify first. It really doesn't matter which way you go. Some people prefer to multiply first, some people prefer to simplify first. So for this one, I'm going to go ahead and multiply first, and the reason I'm choosing to do that, not because I have to, is when I multiply these together, it's not like an extraordinarily large numbers I'm working with. So like if this was 16 and say like 75, I would probably go ahead and simplify first, but everything's pretty small, so I'm going to go ahead and combine like terms first. So I'm going to multiply my coefficients together, so 3 times 2, I'm going to multiply that. So that gives me 6, and then I have the cube root, and then now I'm going to go ahead and multiply my radical pieces together as well. So this is just 16 times 1, x to the 4th times x, so I have 4x's, 1 more, so that would be a power of 5, and then y times y squared, so 1 and 2 more make 3. So now I'm just going to go ahead and simplify it like I did on the previous. So we already talked about 16, right, factors of 16. So I'm going to just go ahead and write that out again. So we know we're going to use the 8 times 2, right? Because 4 times 4, I don't know the radical or cube root of either 4. And then x to the 5th, of course, and then y cubed. So I already have that 6 out here. And so I know the cube root of 8 is 2. So the cube root of 8 is 2. And then I don't know the cube root of 2. So let me go ahead and set my radical up over here. And then x to the 5th, so 3 goes into 5, so 3 goes into 5 once, right, with 2 left over. So 3 goes into 5 once, so 1 here, with 2 left over, so the remaining terms here. And then 3 goes into 3 once, so that would be y to the 1st, with none left over, so none in there. Okay. So then I can multiply 6 and 2 together, and then I don't need the powers of 1. And there's number 20. Okay. Okay, so for 27, the directions here were to rewrite from exponential form to radical form. So I know this is an exponential form because I have y to a power. So for radical form, I need to rewrite that into improper fraction. So I'm going to just start with that piece there. So I have 1.25, so just starting with that. So that's the same as 1 and 1/4. And so that's a mixed number, so now I want to change it into an improper fraction. So I'm going to do 4 times 1 and then plus 1. So 4 times 1 is 4, plus 1 is 5, and then over the same denominator. So 1.25 is the same as 5/4. And so for here, so then rewriting it, then I'm going to have my base is y, and then I'm going to put it into radical form. So this is my power, and this is my root. So the root is in the denominator, so this would be the fourth root, and then to a power of 5, right? And then that is the same exact thing, right, as the fourth root of y to the 5th, okay? So it doesn't matter which way I write it, those are both the same. And so I should look to see, can I simplify that a little bit further? So all I need to know is, so this is a power of 5, does 4 go into 5? And of course it does, right? So I can simplify this. So 4 goes into 5 one time, and then with 1 left over. So 4 goes into 5 once with 1 left over. Okay, and then again, I don't need any of those powers of 1. I can just write it like that. Okay. All right, and then question number 20. So that one was asking us to change it from radical form to exponential. So radical to exponential. So I'm just going to group that 2xy, because that radical acts like a grouping symbol, just like the parentheses do. And then it's a power of 6 and a root of 3. So a power of 6 and a root of 3. Okay, so power in the numerator, root in the denominator. And then 6 divided by 3 is 2. And then I can go ahead and square everything out. So all of these get squared, and I can distribute a power over a product, right? So I can go ahead and do 2 squared, x squared, y squared. What I could not do, though, is what if these were all additions? Could I distribute a squared over an addition? And I can't, right? So keep that in mind, right? So we can distribute an exponent over a product, but not a sum. So 2 squared is 4, and then x squared, y squared. Okay. All right, we can do 2 more here, 2 more. Excuse me. Okay. All right, so for 42, again, we're asked to simplify this. And so I'm going to go ahead and rewrite this as a radical. So this would be the fourth root to the negative 1 power. Okay, so fourth root to the power of negative 1. So the fourth root of 81, so like if you don't know this, you can always do like factor trees, right? If you're not sure of your roots, you can always do a factor tree. And so it takes 4 3s to make 81, so it's like the same as the fourth. So the fourth root of 81 would just be 3. And then to simplify the powers, so how many times does 4 go into 12? So that would be 3 times. And then none left over. So the fourth root of 81x to the 12th would be 3x cubed. And then don't forget that's still to that negative 1 power. So here, so I could distribute the negative 1 into all of that, but the negative is just making that be a reciprocal, right? So if it's negative 1, we just need to do the reciprocal of that. So the reciprocal here would be 1 over 3x cubed. And then finally for 57, we are asked to rationalize the denominator. So that means when we want to rationalize the denominator, we want to make sure that what's in the denominator are rational values, meaning not your radical, right? So we need to basically make this be integer values, no radicals there, right? Okay. So first thing I'm going to do is go ahead and simplify this just a little bit so I don't have to fuss with such a big number here, right? Because 16 right now, you know, like I can multiply by 16 squared, right, to get a grouping of 3 of them, but I don't want to do that, right? So I want to try to simplify this, you know, make my numbers more manageable. So instead of 16, I'm going to think of it as 4 squared. Now, I could also do 2 to the 4th, right? Like, because 16 breaks down, you know, as a lot of things, right? So, you know, it's 4 times 4, 2 times 8. It can also be, you know, 2 to the 4th. So there's a lot of things I can work with on 16. But in particular, what I want to pay attention to is that I have 4 squared here. And so in order to take that cube root, so this to be a perfect cube, I need to have to a power of 3, right? So it needs to be cube root to a power of 3 or any multiple of 3. So that means I need to introduce one more 4, because 4 squared times 4 would give me that 4 cubed. And I need to introduce 2 more c's, because that's a power of 1, and I need it to be a multiple of 3 on that power. So this would give me 4 cubed, which I can reduce, and then c cubed, which I can reduce. And whenever I multiply to the denominator, I have to multiply to the numerator because that is equal to 1, right? And I can always multiply by 1 without changing value. So multiply across the top here. And then when I multiply this grouping together, I would get 4 squared times 4, which is 4 cubed, and c to the first times c squared, which is c cubed. And so now this will then now get rid of that radical in the denominator. So the cube root of 4 cubed would just be 4. The cube root of c cubed would just be c. And so now I have a rational denominator. Whoops, can't see that. There we go. Now I have a rational denominator. Okay, and that's it for this one.